I'm Chad, and I'm here with Vince and Steve in the audience here. We're from Dialogic. Dialogic's been enabling real-time communications developers for more than 30 years. So the demo we're going to show today is our real-time media processing platform. You could also call it a media server, MCU, transcoder. It does all that. It's a virtualized, cloud-ready media server that handles audio, video, WebRTC. It supports the standardized media server interfaces, a RESTful interface, and we also support all the production interfaces to make it easy for application server vendors to interface and take advantage of our real-time communications media processing capabilities. And what are those real-time media processing capabilities? Well, really the server-side media processing use cases that apply to WebRTC that we help with are multi-party conferencing, bringing in multiple participants into a real-time video or audio session, transcoding, converting one codec to another codec, interworking with existing WebRTC media, with existing VoIP media out there, doing recording of audio and video, stream processing, manipulating the audio or video stream, helping with voice activity detection, that sort of thing. And we also get into a variety of person-to-machine applications as well. So we've demoed here now. This is our fourth time. I think many of you have been here before. I've seen this. The typical MCU style approach to doing video conferencing is to more or less multiplex all the video streams into one feed. Vince will show some of the benefits actually of this approach for reducing processing power and bandwidth that's required on a client, which is especially important for battery powered devices. But one of the real challenges with this is it looks ugly. It's not very pretty to have a monolithic block like that. So we worked with one of our newer partners, Dialogic, to see if we can make something that looks prettier. So I'm going to hand things over to our developer evangelist, Vince, over here to walk through the demo and show what we did.
Thanks, Chad. So Chad had touched on it already, but 2 points to keep in mind while we go through the demo is that this is not a peer-to-peer demo. Everything we're doing is running through our media server. So this laptop on the end here is XMS. It's loaded with our software running with the Dialogic code that was provided to us. One thing to note on that, this is a pure web environment. So they're using Node and using REST under the hood to talk to our media server. So that's the one point. The second point is that just because it's server side doesn't mean you don't get the nice client side look and feel. So what we're going to do today is show a conference and be able to fancy it up a little bit. So right now we have Steve in the audience using our Nexus, and we're all going to be using WebRTC VP8, and we're going to have a couple laptops be joining here as well. So if you don't mind.
Do you want to show the simple demo first? Or?
Let's just go to
show the image. Yeah.
So point you out to the audience here. All right, just give me a hand holding this. All right, so as you can see here, we have multiple streams going into this. This is all being mixed on the media server. So as of right now, we have 3 streams coming in. What we can do with this also is start inserting content. So we can insert a newscast as well as our corporate network fuel video. In addition to this, we can also toggle the layout. So this is all, as Chad showed before, this is coming in as one frame. But on the HTML5 side, on the client side, the Dialogic team was able to help us cut the video up. So on the client side, now we can actually move these around.
I'll show the CPU monitor.
Yep. And you'll notice, although it's a bit small probably, As we're adding streams to this, the CPU usage is remaining about the same, although mine is pretty high to begin with. As I add more streams, the CPU is going to remain the same. So the client-side benefits you're getting of having all the streams be mixed on the client side, yet the slicing and dicing of the streams on the client side, you get the benefit of that. So we got a couple minutes left, and just to show a couple more features here, we also have the ability to record the content on the media server. So coming over here to record sessions, and if you could just wave. Stop it, and we could play it right back into the conference. All right. We also have the ability to stop any plays going on at the time and move the video over to the big screen. All right. So just as a shameless plug here, a bonus demo here, we were a participant in last week's TAD Hack, and part of the hackathon was I submitted an application to the hackathon. So this is all going to be going over the in-house Wi-Fi, so let's cross our fingers here. So my hackathon was basically using the WebRTC capabilities of XMS to do a virtual lesson. And in this case, it's a golf lesson. So it worked. So on the left, you have your teacher, and on your right, you have a peer. So this is all going through an XMS hosted in our Parsippany offices. And this is me, obviously, in my backyard, hitting golf balls into a net. So what we have the ability to do now is, because this is server side, we could pause the play, and it also happens on the peer side. So this essentially is showing a student and a teacher on the same screen, but essentially they could be anywhere in the world. With the same capabilities, you could do a step back and a step forward, and then a resume play. You could also switch the views. Maybe. All right. Maybe the demo gods weren't my favorite today. So.
Well, it's a good thing you already won the TAD Hack.
Yeah,
so
yeah.
I can judge now.
But that's our demo. Do you want to wrap up with anything?
Yeah, I just want to emphasize server-side media processing really to help improve video quality by consolidating and optimizing the streams. It doesn't limit your options in your user interface design and user experience. Thank you.
Thank you.